Good day, viewers. Welcome to this edition. Today, we'll be looking at the topic dimension under the subject physics. We'll be considering these questions, which is show the dimension of the following quantities. The quantities are velocity, acceleration, and force. We want to show the dimension involving these three quantities. But before I do so, don't forget to always subscribe to this channel so that you will be notified when next I drop new video regarding the subject physics and chemistry. So please, let's take it step by step. We are going to be looking at the dimension for velocity. Of course, we know that dimension is represented a quantity by the three basic fundamental quantities, representing a quantity with the three basic fundamental quantities, which are simply the mass, the length, and the time. So we want to use these three basic fundamental quantities to represent these quantities: velocity, acceleration, and force. Now, let's start with the first one, which is velocity. Now, from the definition, we know that velocity is equals to displacement over time. Velocity is equals to displacement over time. Now, the dimension for displacement is L. The dimension for displacement is L because displacement is also referring to as the length, the distance, the length. So the dimension for the length there is L, while the dimension for time is T. That means that velocity has a dimension of Lt raised to power 1. Lt raised to power 1 from the law of indices. L over T is same thing as Lt raised to power minus 1. Then let's look at the second one, which is acceleration. And of course, we know that acceleration is the rate of change of velocity over time. The rate of change of velocity over time. If acceleration is the rate of change of velocity over time, that means that we already know that the dimension for velocity is simply Lt minus 1 over this same time. So it therefore means that the dimension for acceleration is simply Lt minus 1 times T minus 1. And from law of indices, we know that when a base is carrying a power, you pick one base and you add up the powers. And we add this, becomes Lt raised to power minus 2. That's T minus 1 plus minus 1 will give you what? Minus 2. So this is the dimension for velocity, dimension for acceleration. Then let's look at the third one, which is the dimension for force. The dimension for force. We want to represent these quantities by these basic fundamental quantities, which is the mass, the length, and the time. So force is simply mass times acceleration. Mass times acceleration. Mass times acceleration. Now we know that the dimension for mass is capital letter M, and the dimension for acceleration is Lt minus 2 from our previous solving, Lt minus 2. That means that the dimension for force is Mt minus 2. Thank you, and thank you for listening.